Hello everyone, I'm Anuj and today we are exploring a short demo AI chatbot featuring Gemini Nano in your browser. So what are we building today? Today we'll be building this sample small Gemini RAG chatbot that runs completely in your browser offline using the Gemini Nano model that the Google Chrome and Google Gemini team shipped recently in Chrome 138 plus. So the main features of this are basically you can create a new session by clicking on new chat on the left hand side. You can upload your own documents. You can select the AI personality. You can tweak the model parameters like the temperature and top K, and you can chat with the chatbot all locally in your browser without sending or making any API request externally. So all your data remains local on your device. So let's take a look at the system architecture. The high level map, this links every component that you'll see next. So first of all, when the user opens the app and wants to upload a document, you can drag and drop a document on the left hand side. The document processing pipeline kicks in automatically once the document is uploaded. So we upload the document, then we use the pdf.jas library to extract the text out of it. Then we start chunking the text using predefined chunk sizes and overlapping sizes. And then we create chunk embeddings out of that. Next, what happens when the user creates a new chat, a new session is formed. Inside the new session, when the user asks an input query, we convert that input query into the input embeddings. And then we use cosine similarity to figure out which relevant chunk embeddings are closest to the user query embeddings. Based upon that, we retrieve the top k chunks out of that. These chunks, as well as the user input, as well as any conversation history, are sent as a prompt to the Gemini Nano model for inference, and then we get a streamed response out of that. So model initialization and session setup is the first step. First of all, we check the model availability on your device. If the model is not available, we download the Gemini Nano model as well as the TensorFlow.js embedding model. Once the Gemini Nano model is downloaded, we check that whether the model is available or ready to download. And if everything goes well and it's available, we then can go ahead and create a session. For document processing and RAG pipeline, we have a small Gemini RAG chat class where we define our our RAG sessions, the documents that have been uploaded, the embedding model, the document chunks, maximum chunk size, overlap size, and so on and so forth. The maximum chunk size here, I have kept it as 500 and the overlap size as 50. I tried playing around with this and increasing the chunk size, but after a certain limit, I got some errors regarding the context length. So that's why these are the best ones that worked out for me, but feel free to play around with these. Then we set the model parameters, which are temperature and top K. By default, I'm just using the default parameters, but in the chat UI, you will see on the very left-hand side, you can use the sliders to change these values as well and play around with them. Next, document processing and RAG pipeline. So once you have uploaded the document, behind the scenes, we automatically start parsing through the document, creating chunks out of it, using the chunk size and the overlap size that I showed in the previous slide. And then we also generate the chunk embeddings out of that so that they are ready when the user query comes in. Then once the user gives an input, we create query embeddings out of that and perform cosine similarity with respect to the relevant chunk embeddings and get the top k chunks out of that. And that forms our context. Then we take this context along with the user query and any conversation history and send that to the Gemini Nano to give the response. So we can retrieve the context, add the conversation context, and send that as context to the model. Then we perform model inference. The model gets the context in user query, does the prompt engineering, which is basically formatting them into the prompt, send to the Gemini model, get the streaming response, and show that on the UI. The model parameter management is basically setting the temperature and the top key and playing around with those values for the model. By default, we use the default values, but feel free to play around with them in the UI. System prompts, I have provided 4 different system prompts which basically act as different roles. There is a general assistant, which is basically the model itself, the academic researcher, where the model tries to act like an academic researcher or as a business analyst or a creative writer. When you choose each one of these personas, the model tries to generate answers based upon these, and you'll see some variations in the responses. We have also the session management, which uses an abort controller provided by the Gemini team to stop each Gemini session. This is very useful to have an automatic cleanup that prevents any kind of memory leaks and zombie streams, which could cause app crashes. And we also have a one-click stop generation button that maps to the stop generation method that stops the generation of the model if you want to stop that or interrupt that in between. Chat history management is also present. So whenever you create a new chat, the entire new session is created and the entire session contains your entire chat history. Now, if you want to create a new chat session, you can click on left hand side in the new chat and it will create a new session and it will contain all the chat history related to that. Each session has its own chat history, so you can go back to that anytime and still continue with where you left. The chat history is lazily loaded and sorted by the last activity. It's clickable to restore, and they are all stored locally in the local storage. The chat titles for the chat histories right now are auto-generated from the first user question, but later on we can, of course, summarize the conversations or use more smarter ways to figure out the titles for these sessions. Context restoration and persistence. So the last 5 user assistant exchanges that are done are kept in conversation context for relevance, so that when the user asks a question that is relevant to the past question or past answers given by the model can still relate to that and use them as context and answer based upon that rather than going from scratch. The context is restored on the chat reload to maintain continuity as well, so that if you refresh your browser or if you close the app and come back to that again, you can still see your chat sessions there as it is, and you can continue with where you left off. It combines historical dialogue with freshly retrieved document chunks, as I showed you before, so that you have much more richer experience in the answers. So let's go ahead and look into the demo. For the demo, I have currently hosted this into my GitHub pages where I have this demo on device RAG AI chatbot using Gemini Nano in the Chrome. I have already downloaded the Gemini Nano model in Chrome and I've enabled it. Please refer to the Gemini's documentation on this. They have pretty detailed documentation about how to enable the models, how to download them for the first time, and use different features. So let's go ahead. So this is my landing page for the Gemini RAG chatbot. And here I'm just defining about some powerful features of this, which is Gemini Nano integration, document processing, intelligent chat, chat history, responsive design, privacy first, and so on and so forth. And here are the system requirements. You need at least 4 gigs plus RAM on your system as recommended by the Gemini team, as well as a modern processor, Google Chrome browser. Internet connection is required only for the first time when you're downloading the model and the embedding model. After that, it's not required. So let's hit launch application. What you see here is 2 statuses. One is the model ready and one is the embeddings ready. So the model's ready basically is saying that the Gemini model has been loaded and is ready for inference. Similarly, the embedding model has already been downloaded using TensorFlow.js. It's a simple sentence embedding model. You can play around with a bigger or a better model as well. So now both the models are ready. Let's look at the UI. On the left-hand side, you can see the AI personality as I've shown you before. We have creative writer, business analyst, academic researcher, general assistant. All of these have their own system prompts that define how the Gemini responds to the user queries based upon these personalities. Then you have a drop down where you can play around with the temperature and the top K. You have the slider using which you can change these values. I'm going to keep them as default. Then you have the upload document section where you can upload your PDF documents, text documents, etc., which will be parsed and chunked, and the chunk embeddings will be created, and everything will be happening in this browser itself. Nothing is going to the cloud. There are no API calls happening behind the scenes. Then you have chat history sessions management where you can manage your chat histories. You can come back to them anytime. And again, these are also saved locally in your browser. So let's create a new chat and start asking some questions. Hello world, what model are you? So as you can see, it's giving an answer which is streaming in the output so that we don't have to wait till the Gemini model generates the final output. This basically helps hide the latency in the UI from a user's perspective. So if you can see, we chose the AI personality as creative writer. So it's trying to be a little bit creative here. Think of me more like a skilled storyteller, have access to a library filled with stories and so on and so forth. Let's change the persona to academic research and ask the same question again, maybe. Hello world, what model are you? Okay, so this time it gave the better response from an academic researcher point of view. It said I am a large language model trained by Google. I am currently running version 3.5 of Palm 2. I don't know if this information is correct or not. I don't think so. But of course, you need to understand that this is a Gemini Nano model, which is pretty small model that is running locally. So it can also make some mistakes. So just be sure of that as well. This means I'm trained on massive text data sets. I can perform wide range of tasks. So this looks correct. I'm constantly being improved. For example, I may not have access to real-time information and so on and so forth. So yeah, this looks like a good response. Now I have two research papers open that I'd like to show you a demo of. For my first paper, I have this Transformers paper, attention is all you need. So I would like to try this out and see how it performs on this. So let's upload this paper. Attention is all you need. Let's go to the UI, drag and drop the paper. So behind the scenes, what's happening is the paper text has been extracted. The chunks have been created using the embedding model, and the chunk embeddings have also been formed. So that means my paper is already ready. I can start asking questions. What is the title of this paper? Okay, so title of the paper is attention is all you need. That's correct. It also gives the citation that okay, the authored paper was authored by these people. Paper introduces the transformer, and since it's a academic research, it also shows that it tries to give some kind of future research directions because it's an academic researcher. So it's trying to show that personality here as well. Okay, so far so good. Let's ask another question. Maybe I might want to just have a summary of what this paper had. It's been a long time. Summarize this paper in 5 bullet points. Okay, so looks good. It says attention is all you need. That is correct. It's trying to summarize it in 5 bullet points. It is making kind of 5 points. So it has the introduction. Paper introduces transformer. That is correct. It has self attention. That looks correct. Then it introduces self-attention mechanism, tries to showcase that. That looks correct. Then shows the transformer architecture, two main things, encoder and decoder. That looks correct. Then it shows the experiments, what the authors have done on variety of tasks, including machine translation. That is correct because the transformer model was trained on English to German translation tasks. And then also text generation was also shown. So this is also correct. And then it tells about the significance of it. Transformer use self-attention, significant advancement in NLP. This is also correct. So this is then summaries provided based on context and focuses on the key concepts. For a more comprehensive understanding, read the paper itself. So yeah, I mean, so far it's so good. So this looks pretty good. Let me try and refresh this. So when I refresh it, what you see is that although my PDF is gone that I uploaded, my session still exists. So now I would like to create a new chat session and show the same demo with a new paper, the next paper that we have. Let's create a new chat session. Maybe I'll change the assistant mode to a business analyst personality because the next document we are going to look at is Alphabet's revenue results from fiscal year 2024. So let's see how Gemini Nano does on that. So first of all, for doing this, again, we'll drag and drop and import our document right here. We got the document. So again, behind the scenes, it's reading the document text, creating chunks out of that, creating chunk embeddings, and it's ready. So let's see what questions can we ask it. So first of all, I guess the document is comparatively a little bit complex for people who don't understand the revenues and those kind of things that nicely. So maybe what we can do is we can ask it to give an overview of this report maybe first. So let's see how it does that. Give me an overview of this report. How is Alphabet doing financially? Let's see how this goes. Okay, so Alphabet's Q4 earnings, key takeaways, strong performance, 12% increase in consolidated Alphabet revenues to $96.5 billion in Q4. Google services dominate, Google Cloud growth accelerates, segment operating results, financial health, actionable recommendations. So again, you see it's a business analyst role, so it tries to give the analysis in terms of financial health and what are some recommendations as a business analyst based upon the revenues that it has seen. So let's first of all see do these numbers match to the document that we have. So 12% increase, 96.5 billion in Q4, 12% increase year over year, 96.5 billion. So that matches 10%, $84.1 billion, 18%, $12 billion in Q4. So it messed up a couple of things looks like here. So $12 billion is correct, but it's not 18%, but instead 30%. Okay, so again, one of the things that you see for this demo is that this is using a comparatively small embedding model. So you can try play around with a better or a bigger embedding model, and maybe you can get more relevant chunks. But overall, this still looks good for a demo purposes. So let's ask another question. So I don't know what all the things are there that are covered under the Google Cloud revenue reporting. So I would like to understand that. So what products are included in the Google Cloud reporting? Oops, sorry. Reporting. Google Cloud reporting. So infrastructure, application, other services like cloud AI, machine learning, cloud identity, access management. Yeah, that sounds good. Cool. Maybe we can ask a more intriguing question. So, what were Alphabet's total revenues for Q4 2024 and the full fiscal year 2024? Total revenue. Okay, so total revenue was also covered in the first answer, which was 12% increase, 96.5 billion in Q4. So this is correct in Q4. And fiscal year 2024, it's saying $350 billion. I am not sure about this. Let's take a look in the document. Does the document mention anything about $350 billion in terms of revenue? So looks like it's taking this value in terms of the revenue. Okay, looks good enough. So one last question. What are the main sources of revenue for the Google services segment revenue? Okay, so Google services consists of advertising, consumer subscriptions, sales of apps and in-app purchases, and so on and so forth. Pretty good. Thank you. I have never tested this. Let's see what it responds. Exploring. Da, da, da. Always happy to help you analyze document answers based on this. Sounds good. So that's pretty much it for the demo. Hope you liked it. Any kind of feedback, comments, please let me know. Any kind of improvements that I can make on top of this. Again, one of the things I forgot to mention initially is that I'm not a JavaScript expert. This has been mostly from my learnings and from the documentations that Google has provided and trying out some things here and there. So please feel free to provide feedbacks and comments on top of this and hope you enjoy this. Happy hacking.